Hello and welcome back to my RC channel. I'm Andy RC and today I'm going to be building, setting up and flying the RCExplorer baby tricopter. Now all of this is possible because of the Let's Drone Out podcast, which is a weekly show on a Thursday night at 8 PM UK time, and I was lucky enough to be on an episode with David Winderstall, formerly of Flight Test, who is a pioneer of the tricopter and is the creator of the baby tricopter. And I was embarrassed to admit that I had never flown a tricopter before, and he has kindly sent one in to the channel. Actually, he sent it to Jack and he brought it up to me a couple of months later. So this is a 2018 build of the baby tricopter, but it's not a whole lot different than David's build video, which is a fantastic video, and he's much more of an expert than me, so I'll link that in the below if you want to watch that. However, there are going to be some different things in this video. For example, the setup has changed. You know, we're using Beta Flight now, and Triflight has been put onto Beta Flight, so that's going to be different. So the frame is the baby tricopter frame. The motors are the red bottom Emax 2205 2300 kV. These are not the stock props, however I did do the tail tune and the line of sight flight on the stock props. The ESCs are a 35 amp 32-bit ESC, so that is different compared to David's video, and also different is the camera. I'm using a micro Sparrow V2, so I've used these 3D printed mounts there at the front rather than the HS1177 mount that it's designed for. We have got the PDB down here, and then we've got the RCExplorer F3 flight controller, and then we have got the XM Plus FreeSky receiver, and I'm going to be using the Taranis for this. Then the VTX is the TBS Unify Race. It's the HV version because it's running off VBAT. And then we have got the RCExplorer servo and also the tail mount. And this is the Brain 3D Tooth Fairy Gopro Mount and a Session 5. This is one of those AXII copies that I'm using for the antenna, and then the battery is a Tattoo R-Line 1300 milliamp. Now there's no on-screen display on the flight controller, but there's an on-screen display on the camera, so that's something that I've added on there as well. So let's get onto the build. So starting off with the frame, and it's advised to file it down. Now this isn't something that I usually do, and the diamond file wasn't included in this kit, so maybe they've changed their minds on that. I would, however, advise to at least file down where the cable ties go through the frame, because the sharpness of the frame and the tension on the cable ties over time, I would imagine, could snap them. Now it's customary to tell a joke in these videos, and all the jokes I came up with were inappropriate, but let's try this one. What's the difference between Andy RC and a quadcopter? Well, at the end of the flight, the quadcopter stops whining. Okay, so this is the power distribution board, and I'm tinning up where the battery connector goes. So this is a Hakko soldering iron, and I'm using 60/40 solder, and this is where the back ESC solders in, and then this is the jumper for the 6V for the back, and that is for the servo. It's advised to use 6V, so just tinning up the rest of the board here. And then this is the XT60 connector, so just tinning up the positive and the negative, and it's advised to cut the wire back a little bit longer than usual so that you can get a nice solder joined to the PDB. So that's the positive going in there, and then the negative. So this is cutting the motor wires shorter and cutting the middle one even shorter so that you get a even solder on the ESC board. So stripping those and then tinning this up. You need helping hands. You need to use blue tack. No, I'm fine. Thank you very much. Okay, so now I'm tinning up the ESCs. These are the 32-bit ESCs. And then I'm going to solder the motor wires direct, and we will change the direction in BL Heli Suite a little bit later. And then in the ESC packet you're given some heat shrink, so I'm going to take that and put it over the top and then use a mini heat gun to shrink that down, and I'll speed that up because it takes a little bit of time, that does. So now I need to do exactly the same with the second motor, so I think it's time for another joke. What is the difference between an FPV YouTuber and a pizza? Well, a pizza can feed a family of 4. True story. We've got time for another one. What's the difference between an FPV pilot and God? Well, God doesn't think he's an FPV pilot. Okay, how are we doing here? So yeah, this is the second one going in, so make 2 identical ones of those. We've got time for another joke. What's the difference between Andy RC's music and Beta Flight? Well, people don't unsubscribe from his channel when he posts a tune for Beta Flight. Okay, I think that's enough. So this is the last motor that goes at the back, and we don't cut the wire shorter, so I am leaving the length and then tinning that up. And then you see you solder this one in at an angle, and that is so the wire can go around the servo, and then I'm cutting the heat shrink a little bit shorter as well, and then heating that up. Yeah, so it can fit on the back arm. Look at that fanciness. Okay, this is the tail part. So it's like plastic, and you need to sand it down a little bit so you don't get any friction. So just sanding that down there. And then this is putting the screw in, and it's advised that you screw it all the way in and then just keep twisting it so that you sort of dig it out and again get rid of any friction. Then this is the servo going in, and then you screw that in, and you can see the servo gets drawn into the plastic part, and then you can do a couple of turns out. Again, that's just to sort of like release any tension. So this is a cable tie going in over the top, and you're provided these cable ties, and just tighten that up, and you can see there that I'm putting them in opposite sides, and the bottom of the cable tie lies flat, and you get the best effectiveness from doing that. So just tightening those up. They're not too tight though, we don't want to break it, and then cutting those to length. So these are the screws for the power distribution board to sit on, and also the flight controller. Using the pancake method here of flipping it over. And then you're given these little washers so that nothing shorts out on the carbon fibre, so that's those going on there. And then the power distribution board going over the top, and then some nylon standoffs, so just screwing those in. That's the last one that's gone on. So this is the servo wire, and just cutting that to length there, and then I'm just separating them so we can solder them up later. And then this is my wire stripping tool, not as good as the one David has in his video, but there you go. So just tinning all those up. They're not silicone wires, so be very careful, because you know you can melt the cables when doing this. So now I'm putting in all of the screws for all of the motors. I don't use thread lock, I've never had a problem with that. Just make sure they're nice and tight. So yeah, let's just tighten them up at the end there. And then same with the other one. So these are not directional, these ones, so they're all the same direction. And then this back one's tricky, so just 2 screws in there, and yeah, tighten those up. Try not to break the servo when doing it. Okay, so this is the spare servo cable, so we can use this, but if you've got any silicone wire, I would recommend using that instead. But yeah, just separating this here, waste not, want not, and then using my wire stripping tool. So we can use this for the connections to the flight controller. So I'm going to tin all of those up again, though it's not silicone, so you know it can melt the wires, but you know, like I say, I don't like to waste wire when we've already got it. Yeah, so just using my own helping hands there. It's just a pair of pliers with a rubber band around it, very flight test. So this is the back positive voltage, and then this is the ground, brown. And then this orange is the current sensor, which I'm not going to be using, and then this is the VBAT, which I will be using. So this is where the ESC fits, just behind the servo, you can see. And then I'm cutting the negative and the positive to length, and then stripping it with some cutters. Very tricky, this part. And then tinning that up, and then tinning up the positive, and then being very careful with the other components, soldering in the negative. I'm going to remove the standoff so that I don't melt it when soldering in the positive there, and then I'm going to put the screw back in, otherwise you ended up with melted nylon. So then just cutting to length the positive on the ESC, so this side is where all the positive ones are going to go, again removing the standoff. So we've got 3 pads to use there, so that's the positive, and then the negative goes to the other side, so cutting that to length, stripping it, tinning it, and then soldering that up on the 3 pad on the other side and feeding it through the components there. So yeah, we're done with that standoff, so screwing it back in and then unscrewing the one on the other side. So this is the negative on the other side, and then I'm cutting that to length, stripping it, tinning it, and then that's going to solder in nicely on this side, and then put that standoff back in. So again, cutting the positive to length and then stripping that and then tinning it, and that fits nicely again through the components to the other side. So this is the camera connector, and I'm just going to disconnect the positive, the ground, and the video from the connector that it comes with, and I'm doing the same on the Unify connector, and this is just me being lazy so I don't have to solder it up. So completely disconnecting the Unify's connector, and this is the small audio because I'm not going to be using that, and then this is the positive going in for the camera's connector, the ground, and then the video. So that's just going to be plug and play apart from the VBAT sensor, and then just cutting the positive and negative to power up the Unify, tinning that up, and also the VBAT sensor, and then this is going to solder on top of the ground for the back, and then the VBAT, it's going to run straight off VBAT, and then this is the sensor for the camera's on-screen display for the voltage. So this is the flight controller, and I'm going to start tinning stuff up here. So I'm using a buzzer here, and it's advised to do that, at least for the tail tune, and it's good for your lost model alarm as well. So I've got a diagram there, and I'm just going to solder that direct to the solder pads. You have to be careful doing that because they can lift the pads up, and then just securing the board on the other side there. So this is the VBAT going into the sensor there, and this is where the back connects, so just tinning that up there. So that is where the back voltage is going to go through to the flight controller, and then the negative. And then this is tinning up where the current sensor wire is going to go, but I'm not going to be using that. Then this is tinning up the back out for the servo, so positive and negative. So red is the positive and brown is the negative. Then I'm going to flip the board over, and then this is tinning up PWM2. So the orange wire is PWM2, and then the yellow one is the servo feedback sensor. Now I'm just organizing the ESC wires, so pushing it to the back and then putting the flight controller over the top. And now I am tinning up the PWM for the motors. So yeah, the servo acts as a PWM. So just cutting those wires to length. and then tinning them up. And then soldering it up. So I think this is PWM1 that's going in there. Quite tricky to see, so I've put a diagram up so you can see where they go. So again, cutting it to length and then tinning up. And then I think this is PWM3 or motor 3. I'm putting both the signal and the ground in there, although I tend to not do the ground, but I thought, you know, to keep it same as the original. So this is PWM4. So this is some wire left over from the camera, and it's going to be for my receiver. So this is a nice silicone wire, this. So just tinning all of that up there. And then also tinning up the XM receiver. So it's a non-telemetry receiver, this. So I didn't really need to connect the current sensor, but if I ever want to add an on-screen display at a later date, I can. So yeah, signal is yellow, red is the positive, and then black is the ground. And this is my own heat shrink. Shrink that down nicely. So this is tinning up the board for the receiver, and again I'll put the diagram up there. So we have got the ground going in, and then the positive, and then the S-bus. And now I'm putting the nylon standoffs over the top because I am done with the soldering on the flight controller. So that's all of those going in there. Then you get this nice plate to go over the top, so my receiver and the Unify can sit nicely over there. So we have some nuts that go over the top of there. And then you get given this sticky pad with the Unify. So I'm going to use that. And it seems to stick on nicely there. The heat from the VTX doesn't make it come unstuck. And then I've got my own sticky pads here, and then the receiver can just sit there nicely as well. So now I'm using a pencil. I'm going to drill out some holes for the Unify. I did that off camera. So this is the battery plate. So you're given these little washers, and then I'm feeding the screws through, and then the standoffs on the other side actually screw onto these. So just hand tightening those for now, and then you need to tighten those up later. And this is the Unify getting plugged in. So this is a 3D printed mount that I've used for the Sparrow V2 Micro. Same one I use for the Floss, and then that just goes over the front standoffs there. I've plugged the camera in as well. And then this is feeding the Unify through, and then there's some spare screws actually, so that will screw in there. The only thing I don't like about the Unify is the connector's not really long enough, and you'll see that in a bit. So this is the top plate going on. Trying to keep my hands out of the way, which is why I'm screwing it in the wrong place, holding it, should I say, in the wrong place. And then this is feeding the antennas through for the receiver, so nice place for your antennas, using my own cable ties there. So one each side, and then cutting it to length, making sure it's not too long. This is my own 3mm tubing heat shrink, and again using the mini heat gun to shrink that down. And this is the antenna going on. It's a copy of the AXII, and if you look, I can spin around the antenna, which means the pin isn't connecting. Those connector's not quite long enough, but if I use some pliers, I can just about get it make a connection. You see, it should not move. You should not be able to twist it. So then I'm using some electrical tape just to secure the ESCs down, trying to be as neat as possible. Yeah, I really dislike the Unify for that, and the little UFL connectors, although they have an mmcx version now, I see. But man, I've broken a lot of Unifys. So this is also securing down the back ESC, cutting it to length, and again trying to be as neat as possible. So I'm plugging the battery in to see if the servo is in the middle, and it is. If it's not, you can slide it back and adjust it though. But yeah, mine was pretty much in the middle, so I didn't need to do that. So I'm just going to unplug the battery there. And then this is using the two cable ties together so that we can hold the servo down, otherwise it just moves, so we don't want that. And again, you know, you want to make sure it's pretty tight, but not too tight, otherwise, you know, you could end up breaking the servo. But again, yeah, one each side, so the bottom of the cable tie lies flat. And again, cutting those off there, and it's pretty neat. So this is a silicon mat that I'm adding so the battery does not slip. You're not given that in the package. 3M silicon. And then this is the RCExplorer battery strap. So next I'm setting a model up. So I've called it the Baby Tri. So you want no pulses for the failsafe. And then we want D16 channels 1 to 8. Then I'm going to page over. And you can see that I've got my channel 5 set to ARM, so that's what A is, and then I've got it on this 2-position switch here. And then I've got channel 6, and this is going to be for mode, so for angle and acro, and that's on this switch here. And then the last one is going to be for a buzzer, so I've called it B on channel 7, but it's also going to be for the tail tune, and that's also on a 3-position switch there. So just come out of there, and then we can go back in and bind the model. So press bind and telemetry off, channels 1 to 8 for the lowest latency. Plug the battery in while holding down the bind button, and we should get a green and red light for the international version. And then I can press exit on the Taranis, and then when I plug the battery back in, then we'll get a green light to show that it's bound. So let's talk about the issues and the workarounds in getting the baby Tricopter to work in 2018 with the latest firmware. So the RCExplorer F3 flight controller has come flashed with Triflight. So Triflight is a modified version of CleanFlight that is designed to work better with Tricopters. So there's a tail tune feature in there that will make a Tricopter fly better than if you were to flash just normal CleanFlight or Betaflight. Now this might just be because Jack has held on to this package for so long, but this flight controller came flashed with a version of Triflight that no longer works with the CleanFlight configurator. So not so long ago the CleanFlight configurator was changed and brought in line with the Betaflight configurator, which means that the older firmware no longer works with the configurator and you get an error. And that was the case with this flight controller. So I went on the GitHub for Triflight, and there is a newer version that is designed to work with Betaflight. So you can see Triflight version 0.7 and it says beta there. Version 3 for Betaflight. Now it's based on Betaflight version 3.17, so it's not the latest version, but you know, it's not really old either. And I was reading that actually people were getting more luck with Beta 2, so that's the version that I used. And if we come down here, I'm looking for the RCExplorer F3 hex file, so it's there. But there is a further problem. So these are 32-bit ESCs, and I have soldered all of the motors up direct. So I'm going to need to change the direction of one of the motors, and in order to do that with BLHeliSuite 32-bit, you need to be on Betaflight version 3.2 and above. So if I just plug the battery in here, and then select the right COM port, it'll give me an error. You see, it can't connect. Now, there is a version of Triflight but it's in like the testing phase of 3.22, and I didn't fancy trying that because I'm trying to get some good results here. So what I actually did was I went into Beta Flight, and if we go into the Firmware Flash, you can see RCExplorer F3, and we actually have the latest version of Beta Flight there. Now this does not have the tail tune and all of the Tricopter settings in there. However, what I did was I flashed this version, and then that did allow me to put the pass-through on there, and I was able to change the direction of one of my motors. So I did that, and then I went back into here, and then I loaded the firmware local, and then I flashed the Beta 2 back to it, and I was able to carry on. So a little bit of a workaround there, and in short, if you don't want to do that, I would try this sort of test version of 3.2, and then you should just be able to use the B-Alhali pass-through and change your motor direction. But anyways, so let's connect to this now, and I'll show you the settings. So in the ports, we have got the UART1 on the Serial RX for my XM Plus receiver. Then if we go into the configuration, so I've got it set to multi-shot here. I can't remember which version D-Shot came in on Beta Flight, but I could not get D-Shot working, so I've left it at multi-shot. Some people say multi-shot is better anyways. However, if you are using multi-shot, it does mean that you're going to have to calibrate your ESCs, which is fine. Just make sure the props are off when you are doing this. So I've got 8K, 4K there for the PID loop frequency. I've got a serial base receiver and then S-bus down here. And then I haven't got air mode permanently on, and of course we don't have anti-gravity on there, so I put it all in the modes tab instead. But for the VBAT, I've got onboard ADC because I did connect that up, and then I've just reduced the minimum cell voltage so we don't get the beeper going off when the voltage of the battery sags. So that's everything there. So PID tuning now. I did fly with the stock PIDs, and I was getting just a slight bit of tail wiggle, or tail wag as they call it. So I have got these PIDs here that I've worked on, and this is for using in conjunction with a GoPro and a Gopro Mount, and it flew pretty nice with that, as you will see later. And I've changed the rates here, I've got my own rates in there. And I've done the thing with the D-set point weight that Josh recommends to do. I don't know if that's going to make any difference on a tricopter, but I'm going to try it, if you pardon the pun. And I've got the TPA value in as 0.2 on there as well. So receiver, just got it set up as TAER there, and no RSSI because we don't have Beta Flight on screen display. Got some RC deadband in there so we get a nice smooth movement for the center stick. And then if I go into the mode, so I've got it arming on the AUX1, I've got air mode in the second position, so for acro, and also anti-gravity on the AUX2. I've got angle mode over here as well, and if we go down here, I've got tail tune. So after I've done the tail tune, I'll add the beeper in on the AUX3 as well, but I'm going to run through the tail tune there. So yeah, really interesting. It reminds me of the auto tune that we used to have in Pixhawk, but it's for the tail. And you have to make sure that you don't touch any of the controls. I think you can touch the throttle, but if you touch any of the other controls while it's doing the tail tune, then it'll just stop. So you're going to have a really calm date for that. And then in the motor, so yeah, you're going to have to calibrate your ESCs with multi-shot. So tick this thing, make sure the props are off, put the throttle to full, plug in your battery, you'll get the tones. And then bring this down. And that's it. Now if you don't do that, what I found was as soon as I plugged the battery in, regardless to whether it was armed, the motors would spin. So that's a really important one to do. And then if we just go into the CLI, I will show you the version. So you can see the RCExplorer, it's actually showing as beta 2 3.17. And that is all of the setup that I have done. So this is the tail tune device. So you put it in at the back there, plug the battery in, and then we enable tail tune and then push in the aileron. Now this is mode 1, remember, so push in the aileron and it will move to that side, and we can then use the rudder to make sure that it's just touching the bottom of the tool there. Now do this on a flat surface. I had to hold it up to show you, but you see, can move the rudder there and it sits flat against the device. So we put the opposite aileron in, or roll, put the device to the other side and do the same for the other side, and then once that's done we can push forward on the pitch, and then this is how we can adjust the middle point, and you can use the top plate to set that. Once that's done, I'm removing the device, and if we pitch backwards it'll do the servo speed test, and once it's done that, it's done. And I'm actually arming here to test the failsafe, and you can see we now have the tail motor turning, but I'm going to turn off the Taranis and everything should stop. So next I'm putting the props on. This is the correct direction, and make sure you're very careful not to harm the servo when tightening up the nuts. Okay, this is the Maiden Flight. Wish me luck everyone. I'm going to start off in angle mode, and let's arm and give it some throttle. It flies! Yes! Look at that! So I'm going to attempt the tail tune now. It's pretty flat calm, but there is a slight breeze, so I'm going to walk out into the field and I'm going to put it in acro mode, I think, so you can't touch any of the controls, and all of the trims have to be exactly center, otherwise it'll recognize it as a control input, I guess. Right, hover, tail tune, should give me the countdown, and then I'm off the controls and I'm going to try and follow it if I can. I might have given it too much forward angle. But there we go already. Can you hear the beeps? Those beeps mean that it has completed the tail tune. So we now land, disarm. It should carry on doing those beeps. And then I can flick out of tail tune mode and it should save the options. So using David's words, I should now be able to fly it like a maniac. No, I don't think I'm going to be doing that because it's my very first time flying a Tricopter. Let's try a punch out. Oh man, yeah. It's got some power, this thing. Look at that, it flies just like a quadcopter. Oh man, that sun is getting low on the horizon. Let's try a roll. Yes! Try a power loop. Very first Tricopter power loop. Nearly put it into the ground. Oh man, it flies good. Yeah, it's a little strange on the tail with the rolls, but that's to be expected really. But I'm amazed how well it's just flying, following David's instructions. Well done, David, that's awesome. I expected nothing less though, to be fair. That is awesome. Yeah, actually not too bad with the orientation, a little bit easier with the 3 motors. So let's take a look at some FPV footage. Now I did swap out the stock props for the DAL Cyclone 5040, so they're the same in pitch as the stock props, but I thought the DAL prop would give me a little bit more durability, and the colour of them matched the Brain 3D Gopro mount that I was using, which, you know, you should never really take into consideration, but I always do. So yes, this flight is done with the GoPro Session 5 and the Brain 3D GoPro mount. Now I did fly the model FPV on the stock props and without a GoPro, and the stock PIDs, it flew really nice actually. I just got a tiny bit of what they call tail wag, so I thought, you know what, I'm gonna stick the GoPro on there and do a complete tune, because when I put the GoPro on there I got a lot of tail wag, and the way that I got rid of it is I came down a lot on the P gain for the yaw, and I also reduced the I gain on the yaw as well, and that seemed to get rid of the tail wag completely. So I'll overlay my PIDs if you are interested. Maybe you can use them as a starting point, but as a general rule, if you're getting tail wag, I would say come down on the P value and also the I value. Now when I posted that I was going to be building a Tricopter, some people said, oh, why would you do that, they fly awful, and I couldn't disagree more. It flew fantastic, and I can really see why David pioneered the Tricopter, because, you know, I've been around for a while and I've flown, you know, early flight controllers and early quadcopters, and they didn't fly as good as they do now. And of course they have had a lot of people on there, and we've had a lot of improvements, and, you know, quadcopters are much better than they used to be. But one thing that I noticed with the Tricopter is that, you know, especially around the corners, it has what we call flow, or juicy, you know, by today's standards, and quadcopters didn't have that back in the day. And so I can see why people pioneered with Tricopters and still do, because you get that lovely flowing feeling and the turns are just fantastic. But I think, you know, if you are talking about acro and precision, hesitation maneuvers, then the Tricopter is not for that. But I tell you what, it wasn't half fun flying it around and, you know, trying to get smooth flying. You can see that, you know, it has come out pretty smooth, not as smooth as a quadcopter, but, you know, it was just something really nice and different to fly, and I would recommend anyone to go and pick this kit up. It's completely different from building a quadcopter. There is a slight learning curve, but, you know, it easily translates from a quadcopter, and I had a lot of fun flying it. So yeah, I was actually impressed with the Unify race as well. The FPV feed was really clean, you know, that's going straight to feedback without any filtering. So yeah, I really like the race version of the VTX against the Pro. You know, I tend to find that the Pro gets more issues with noise, maybe because it's more powerful, drawing more amps, getting hotter, etc. But yeah, I just want to thank everyone from Let's Drone Out, because this wouldn't have happened if it wasn't for them, and also for David for sending it as well. So I'll link it in the below, and I'm going to leave you with some flying, because you get a right decent flight time with having just the 3 motors as well. So as always, thanks so much for watching. Please continue to subscribe. Cheers.
Oh, you make me wanna talk back to you. Say it like that. If I hate you, then find someone new. Baby, but you know I never will. No, so I choke you down just like a pill. Take you like a pill. but you know I never will. No, so I choke you down